absolutely. Yeah, so I've been a structural engineer for, almost 20 years now. Born and raised in Vancouver, British Columbia, beautiful BC, lots of forests, big trees, and kind of grew up around the timber construction industry from an early age. My dad, Jerry Epp, was one of the founders of Fast and Epp. They're a structural engineering firm who focused a lot in the timber world. And so I grew up seeing all sorts of amazing big timber structures getting built and designed around me. And then I actually went and moved over to London in the UK and worked there for about 5 years at a firm named Bureau Happold, doing all sorts of stuff, nothing to do with timber at all, actually. It was all steel and concrete and, big, crazy kind of complex designs with Zaha Hadid. Worked on a pretty cool tower, actually, in Kuwait City. It was 1,000 feet tall, with Foster and Partners. Worked on that for a few years, and a lot of really interesting kind of non-timber experience. And then moved to New Zealand for a couple of years, actually in Auckland. Worked there, and then finally made it back to Canada, almost 10 years ago now, and started kind of a structural engineering team inside of StructureCraft here, where I currently work, and now the vice president at StructureCraft, to help and run the company and kind of set the future direction. And we're involved in all the way from kind of structural engineering, concept design, all the way through to construction and running installation of these big timber and steel hybrid type structures.
It's amazing. And it might be worth going through the history of StructureCraft as well. So what did it start as, and like what sort of model is it sitting with right now?
Yeah. So StructureCraft, it's a really interesting company. It's actually quite unique in our field, because it kind of bridges a gap that has been created over the last couple hundred years, where we've seen this kind of specialization and kind of almost divergence in our industry of the design side moving away from the construction side, and designers maybe getting further and further away from the people that make. And there's always been a lot of interest, and some of the best designers are those that do make or are very involved in the process of creation and actually building what they design. And StructureCraft started 26 years ago now by my father and Jerry Epp, and he founded it because actually he was working on a project downtown Vancouver. It was the new aquarium, and it's in Stanley Park, which is this beautiful kind of forest almost on a peninsula right in downtown Vancouver. And the architect had envisioned this gorgeous timber and steel roof over the new aquarium. And then they put it out to bid, and they literally got no bids. The contractor came back and said, "We can't build this. You guys go back to the drawing board, redesign it as steel. I got lots of steel subcontractors who will build something for you. But this whole timber thing you've envisioned, forget it." And my dad turned to the architect by the name of Bing Tom, a famous Vancouver architect, and he said, "You know what, Bing, we're going to build it for you." And so that was literally day one of StructureCraft, was figuring out how to build what others said was impossible, or what you designed, but was coming in too expensive, or people didn't know how to actually build it. And so that was project 001 for StructureCraft, was building, designing and building that new roof over that aquarium. And now 25 years later, we've grown significantly, and we work all across North America and also in Asia, and we have some increasing presence in Europe as well. And so we as a company, we started off almost as a subcontractor, so really focused on the construction side, and my dad and his engineering team at Fast and Epp would be doing the consulting engineering and design, and then StructureCraft would be involved in the construction side. And then about 10-12 years ago, about 10 years ago, we split off of Fast and Epp, and so we actually separated, and we started our own consulting engineering capabilities inside StructureCraft. And so now we actually offer full service, all the way from being the engineer of record through to manufacturing and construction on the construction side. And so we kind of harken back to this master builder approach, this idea where there was less separation between the people who ideated, the people who designed, and the people who actually build. And so that's a really interesting business model. It's obviously design build is very common in many parts of the construction industry. You look at civil, right? Or you look at big infrastructure projects, or even, larger public-private partnerships. There's a lot of industries where we do see that happening a lot, but in the traditional buildings world, it's perhaps less common. And we see this design bid build procurement model being kind of the predominant way things get delivered. And so, our company is maybe, challenging the status quo to some extent, with a particular focus on mass timber of, a product and a material and an engineering material, which is less understood and newer, and, seeing the value that could be brought by understanding in a lot of detail how to fabricate, how to build, how to install, and how that can affect how you actually design, as a structural engineer working, in partnership with architects.
Yeah, amazing. And yeah, so your dad, Jerry Epp, you did Fastnet and StructureCraft. That's one hell of a legacy. Not many people around the world have actually had that influence. So cheers to him. So a little bit on the old model. So like, you used to work obviously at Bureau Happold, and a lot of people listening probably come from like a tier one traditional background, maybe. What is the difference where you can be siloed basically in that, and why is this area mass timber so different, and sort of what are the, because if people a lot of the time learn through scars, I guess. So like, what are the scars that if you apply the old approach that you're going to get basically, and if you don't actually have that master builder mindset and multidisciplinary sort of approach to things?
Yeah, it's a great question. I think mass timber being, a nascent building material has a unique set of challenges, and it's different from, say, prefabricated steel or precast or some of the other pre-engineered building products. It's got its own set of unique constraints and also its own set of unique advantages. I like to talk about batch size one manufacturing, where with mass timber, every piece can be custom for very little difference in cost than every piece being the same. And, that isn't necessarily true with steel. And so if we just maybe make a comparison to the steel industry, with steel, the effective ways and efficient ways of designing have been out there in our little steel handbooks for, 60, 80 plus years. We know how to do a shear tab, right? We know how to do a moment frame, portal frame. This stuff has been PhD'd and studied for years, and the industry standard kind of efficient approaches have emerged and have been crystallized down into standard design practices. And we now see kind of more of a disconnect, for example, with steel, and you get the subcontractors who know very well how to do the connection detailing, and you get the concept engineers who are doing the overall, structural framing as the engineer of record. And so what we see with mass timber is there's perhaps, given its current stage, more of a direct connection between your understanding of exactly how to design all of the connection details and the success of the overall project than there would be, say, perhaps in a steel structure. I like to say with timber structures, a timber building is a whole bunch of connections held together by members, rather than the other way around. The joints are really where all the magic happens, and where some of the challenges really are. And so I think, if you look at a traditional procurement model, design, bid, build with mass timber, often you lose the advantage, and you often end up engineering maybe a more costly structure than you would if you had known and had a peek behind the manufacturing and installation curtain as you were designing that structure to start with. So I think, in the wider industry, a typical way to avoid that would be using something like design assist, right? Where you get a specific manufacturer or subcontractor on board the design team early, say it's 100% DDs or something, and you're in design development, you bring that manufacturer on to understand, okay, what are those manufacturers' specific constraints, and try to design to those. And that can be effective. But what we also see is that still there's sometimes a bit of a block there, where you get a design assist partner on, but then they get a second engineer, or there's multiple cooks in the kitchen from a design side, and that engineer knows how to do the connections very well, but there's still an engineer of record who wants to set the whole frame of the building up. And so it can sometimes lead to perhaps less efficiency than you would if you had an engineer to start with who really understood all the details of how to design. And so, we see things like, fallout of those types of traditional processes are often, well, the building's too expensive, and we didn't realize until we'd already halfway gotten down the design phase, and now we're just going to go concrete, right? Or we're going to go with a different material. Or sometimes we see impacts like a lot of change orders and a lot of RFIs later because the design wasn't conceived of from the get-go, understanding the details of how to design for manufacture, how to design for assembly.
Got you. One of the things with vertical, the idea of vertical integration is obviously, fantastic. And I think you've got design, manufacture, and build. What are the advantages of vertical integration like that, and what are some of the ways that it might be challenging? And it's one of those things that some in the past, some big players have like gone all the way full vertical integration, and it's
Right.
amazing, but there's obviously challenges there as well. So sort of like, that whole, not in just the StructureCraft context, but that in general, and also like, where construction is now, and also, if we believe construction's heading in this direction, is construction ready, the readiness of construction as well to actually, from a game theory point of view, right? Like if you're moving at the right time and things like that.
That's a great question. I've thought a lot about that over the last 10, 15 years. And I've actually got a couple of fantastic books back from I want to say 1960s, 1970s. They're called Industrialized Construction. And it was a series of books written about all the different ways that our construction industry is working, back then, we're talking 50 years ago plus, to get more efficient. And it was all about taking construction offsite, prefabricating. It went through all the ways the Japanese were doing it, the Brits were doing it, the Americans were doing it, and all these different amazing, building systems that had been created and tried actually sometimes at very significant scale. And you read some of the introductory quotes in these books, and it kind of talks about these like goals, and we need to do better, and we need to get more efficient. And here we are 50 years later, and have we really moved the needle? And so the construction industry is a challenging industry. And I remember when Katerra was starting, and here in the mass timber industry, we get this mass timber conference, which gathers every year in Portland, and you get thousands of people coming. And one year Katerra just took over the whole conference, and Michael Marks, the CEO of Katerra, came in and gave the keynote and told everyone there, he's like, you know what, we're going to come in, we're going to show you guys how this is done. and all of us old industry pros were like, yeah, okay, sure, let's see. And I still remember Katerra, like, they started trying to buy everybody up. In fact, they wanted to buy us. They wanted to buy everybody, right? And they had a grand vision. And actually, in some ways, I kind of aligned with their vision, because I do think that vertical integration, in a lot of ways, is very positive. Now, Katerra, of course, had its own challenges in terms of just taking on too much of that, all the way to like making their own bathrooms and materials, through to, okay, the developer doesn't want to hire us. Well, we'll become our own developer. We'll buy up general contractors. And they just went so broad and so deep at so fast that it was very difficult to really make it work. But I do think that this concept of vertical integration is important, and I think is imperative, actually, if we're going to get to where we need to, from an efficiency standpoint, from a sustainability standpoint. We have to get more efficient. I mean, I'm sure you've seen the McKinsey report on construction innovation versus all the other industries, right? I mean, it's terrible, and it comes back to software too, which we'll talk about in a bit. But I think a lot of it is around how the procurement models are set up, and how it can create adversarial scenarios in project delivery, where you have an owner and their design team on one side of the fence, and the contractor and their subcontracting team on the other side of the fence, and lob change orders and RFIs over the fence, right? And ideally, why does construction have to be like that? I mean, a lot of projects is not. I'm generalizing, obviously, but sometimes it is, right? And so I think there's an opportunity there to really start thinking and looking beyond, and getting getting past some of the barriers that we've seen and really getting to a place where we can become more efficient.
One of the things that comes up in the podcast and people got different perspectives on, which I'm keen for your thoughts, is like, the idea of does form follow function or function follow form, or like another way of putting it is, should we start from like manufacturing throughput, DFMA, perfect grids, and then pass the way up the way to the architect? Or is it okay for the architect to say, this is the building I want, and we're going to actually work back and make that vision a reality? So what are your thoughts on that? And can both exist? Or over to you.
Yeah, it's a great question. My thought is function without form and form without function are neither of those are things.
Gotcha.
And so I think we need to create buildings and a built environment around us as humans that responds to our needs. So it has to be functional, but we need beauty. I mean, us as humans, we need things that we can relate to, that we find welcoming and inviting. I don't think I'm a firm disbeliever in fully rectilinear buildings that are built like out of a textbook, and you just build it all straight and manufacturing optimized, and everything is just as simple and cheap as chips, right? I think we would create a lot of very horrible buildings if we were to take that type of a design approach. So I think what is needed is design creativity is needed, but it has to be manufacturing and construction informed design creativity. We need to have designers who know the constraints inside, not just needing to ask somebody, but really know it themselves. And I think when we get there and we see designers, great designers who have kind of embodied those types of concepts and have gone on to create amazing things. I think of Renzo Piano, I think of Norman Foster, I think some of the great architects who really understood materiality at its depth and then went on to just create incredible things. I don't think the cheapest or the most efficient system is always the right system. I think there's a lot more at play than just the functionality. But at the end of the day, if you build a building that isn't functional, well, then why did you build it in the first place? And we see examples of that in some of the buildings architects have built across the world. But I don't think that it should be one or the other. I think it has to be both.
Yeah, that's awesome. And it sort of links back to that vertical integration idea. Like when I went to the International Mass Timber Conference and looking at your booth, you do have these old Japanese wood connections, which are absolutely amazing and absolutely beautiful. But because you've got the CNC fabrication and you're vertically integrated, you can unlock that beauty and make it work at I assume a cost effective rate. Whereas like the old model, probably, where you've got like, I used to work for a CLT supplier, and if you got those drawings and they're just worrying about manufacturing throughput only, there is that disconnect. So having someone who can bridge from getting billets, CNC manufacturing, and like taking care like that, and mention that intent seems to be like a critical piece to actually connect those two.
Yeah, and to enable more beautiful buildings. I mean, that's one of our goals as a company is to be able to create things that are beautiful, because I think if we create beautiful buildings, then we enjoy our lives more in them, right?
Yeah, 100%. And you've got, like, I encourage everyone to check out your website, because like your bridges and everything you do there is absolutely insane, and some of the most beautiful architecture I've come across. So that's amazing. We did briefly mention before getting onto the idea of software. So you had I think it's been around a while, but you demoed an amazing software that's coming in the future at the International Mass Timber Conference. So we're keen to discuss that, but maybe a step before that, like why invest in software like you have in that direction? And, as part of that vertical integration stack, what can software solve that's not out there today, basically?
Yeah, it's a great question. I think software, I think back to a guy named Alan Sutherland who created this software called Sketchpad back in, I think, 1962. And it was simultaneously the first kind of object-oriented visual programming language. And at the same time, it was the first kind of parametric CAD software that anybody created. And he did this for his thesis in 1962. And so, then started the CAD revolution. And, CAD, computer aided design. Okay, the computers are meant to be aiding us in our designs. And I think they do aid us, but I wonder whether sometimes they also limit us. And I wonder whether the software that we have limits what we as, let's say, a global or broader design community create. And you look at obviously some of the most amazing buildings and architecture in the world, and they're evidently not limited by what a computer could draw or what a computer could imagine. But then you look at, say, maybe 70-80% of your building stock that gets created, and you think, hey, are those buildings, are they tending towards what might be easiest to draw in Revit or Bentley or whatever, right? And is the software that we use as designers actually influencing what we design or what we default to designing? And is it influencing the next generations of designers? I see that in our own structural engineering department. Our junior engineers will, sometimes will get limited by, well, the software can't do that, or this is how the software is built, and it starts to limit maybe your creativity. And so I've been thinking about this for a lot of years, just about how does software work in our industry, and I've just focused really on my own field, which is structural engineering and fabrication and construction, because I think sometimes you try to tackle too much and you fail, right? And so similar with our company, with StructureCraft, we're vertically integrated, but we're only integrated in the structural engineering, manufacturing, and construction of the structure. We're not trying to be a Katera where you take on the whole thing. And so in the software space, I look at me as a structural engineer and how I interface with architects in a traditional sense, and the numbers of pieces of software I need to use to be able to give an answer to an architect. And say an architect wants to explore looking at a different grid, or they want to explore, well, what if we were to do a transfer here, or what if we were going to go with a different material in half the building and a second material in the other half. And the traditional structural engineer would say, okay, great, I can use some rules of thumb to give you a new beam size, or a new column grid arrangement. But give me a day or two. I'm going to go back to my office and send me a Revit model, and I'm going to create a wireframe and import it into my structural analysis model, right? And run some analysis. Then I'm going to crank some spreadsheets to design all my beams and my columns. Then I'm going to go back in Bluebeam and I'm going to mark up a set of plans and send it back to the architect, right? And so you look at that kind of design iteration process, and you think, man, there's a lot of computer blocked design processes in there where the data is not continuous. You can conceive of it all in your head, and you could just do all those same numbers by hand often, but actually often there's, especially with timber, where you could be designing every piece optimally. It's harder to just do it, okay, I'm going to do a quick number on the back of the envelope and then just apply it everywhere, or you end up with a more conservative answer if you do that. And so started posing the question, could we create a piece of software which would actually vertically integrate from that kind of concept design piece all the way through to creating the piece drawings and the CNC files and the manufacturing information that ends up, running the machines that make these pieces of timber or steel. And imagine a piece of engineering software where instead of, the architect saying, hey, what would happen if we make this grid 30 feet instead of 20 feet? And you have to do numbers and a separate piece of software. Imagine if you and the architect could actually just sit there in front of a model and move that grid line yourselves, and in real time see your structure redesigning itself. And in real time, every beam, every column, every piece of the structure is calculating the right size, the loads are updating, and you're able to kind of interact with your model and your design in a different way, completely different way than you might as a traditional engineer in a traditional piece of engineering software. And so started asking ourselves that question. And then about 2.5 years ago, we started creating a piece of software called Branch, which kind of aimed at doing that. And here we are now kind of 2.5 years into it. And we've created a piece of software now, which can kind of, like you said, we were demoing at this Mass Timber conference. it can kind of do some of what I just described. And it's not all the way there yet, but it's kind of incredible now looking back. 2.5 years ago, it's like, well, that didn't exist, and then now it exists. And thinking that our computers are actually really, really fast when you look at it. And the software that we have in our industry is just really, really behind. That's the reality. We haven't taken advantage of the latest advances in technology, whether that be multi-threading, or whether that be using our GPUs, whether that be starting to look at AI and harvesting information and using predictive analytics to help get to a solution quickly while the real analysis might be cranking on in the background. There's a lot of opportunities to use what we have in modern computing and apply them to the buildings industry. But what we found is that the majority of funding and research and development in the AEC industry goes into the C part of AEC in a lot of ways, because that's where a lot of the money is. But of course, all the money we spend on construction was started in architecture and engineering, let's face it, right? And so actually, if you create more efficient software to design buildings, you should be able to save a lot of money in how you build them. And so that's really kind of, I guess, at the core of the reason behind us creating this new piece of software is imagining a world where we could design more efficiently and more quickly, and give building owners and developers an ability to explore more of the solution space. So instead of being like, well, we can only study, a couple of grids and we're just going to have to move forward. Well, actually, no, you can just go study whatever you want, because I'm seeing my carbon update in real time and my price and my material efficiency. And I can just go explore whatever I want to explore and really start to understand, well, instead of letting the computer or our software limit what we design, let's actually just design what we want. And as long as our metrics are being portrayed back to us, it allows us to make better informed decisions, I think.
Yeah, it's super exciting. And then just you were showing also all the way through to shop drawings. So just implicit in that, you've got to solve the level of detail required to get that in your branch software, which is really cool.
Yeah, there's being able to solve we've kind of started at the bottom of the pyramid with branch. So the bottom of the pyramid, being able to create the actual piece drawings and dimensions and bills of materials and the actual CNC files, like the BTLX files and BVX files that actually run the CNC machines. And if you can handle that, and you can handle showing thousands and thousands of fasteners and being able to display models of that size, well, then you can handle all the stuff upstream, which is much lower levels of detail representations of these objects, no problem. And so we've been kind of trying to start at that level. And last year, Branch produced about 600,000 square feet of mass timber buildings in terms of actually making all the shop drawings and actually shipping out all the CNC files. So it's in full use inside our company, which that's also been really fun. Is you develop a piece of software, but your own team's using it every single day, and so you get this amazing kind of direct feedback loop from a software development perspective that most software engineers would never get, because you're multiple layers removed from your end users. Whereas the software engineers on our branch team, they're literally on the other end of a Teams phone call from all of their end users, and there's no holds barred, right? You're getting that direct feedback right away.
Yeah, that's so cool. Well, it's good segue into the final question, Lucas. What do you see as the future of construction? I mean, over the next 10, 15 years, where do you see everything going, and how should everyone best position themselves for what's unfolding?
Yeah, that's a great question. I think it's hard to predict the future of construction. I think it's going to be formed by those companies that are at the leading edge and really pushing and innovating. There's been a lot of spectacular failures, as you mentioned earlier, in the modular space, in the vertically integrated space. We've seen it repeatedly in the UK and the US and elsewhere. But I do think that there also have been successes, and even out of those so-called failures, we've seen a lot of really talented people come out of those companies with a lot of incredible ideas and a lot of, I think, the future thinking and the future framework of how our industry will work in the future. And so I think that we should look for some of those companies to really start making big strides over the next 10, 20 years. I don't think it's going to be fast. I think our industry is extremely slow to change. Just look at mass timber as a material. I mean, first invented back in, I guess, 1910 or so in the US, but then not really reinvented until 1990 or so in Europe, with Gerhard Schickhofer and the guys at TU Graz. And then that process went through to, mainstream over, like, let's call it basically 20 years before we were starting to see a significant volume of mass timber buildings actually built. And still, it's a minuscule fraction of the amount of buildings that are actually, our actual construction industry. And so I think our industry is slow to change, but I think change will come. We're starting to see more progressive thinking from owners around delivery models, and more progressive thinking also from contractors and even architects. We're starting to see more collaborative processes and other procurement methods like IPD and all these types of things which are coming up, which encourage more collaboration between the different parties. So I think we'll see more companies starting to innovate there. I think certainly the next 10, 20 years are going to be the age of timber really coming to the fore. We see projects like, I don't know, British Museum, right, with Norman Foster's amazing steel grid shell. We see projects out of steel right now that in timber are really only rarely dreamed of, or maybe Shigeru Ban already did it 10 years ago, but he might be the only one, right?
Yeah.
But I think we're going to see over the next 10, 20 years those types of projects where architects are really starting to push the boundaries of what's possible with wood as a material. I think it's going to explode over the next 10, 20 years, which is going to be really exciting. And the other area I think that the construction industry is really starting to move on is sustainability. And so we're really starting to see carbon and design for carbon come to the fore across a lot of the buildings and bridges and structures that we're starting to work on. And I think we're starting to see cities and jurisdictions and countries put in carbon legislation. For example, here in Vancouver, the city of Vancouver has recently released kind of a rollout of a carbon reporting and limits for buildings, both operational and embodied.
That's amazing. Lucas, it's been an absolute pleasure to get to speak to you. If people want to find out more about yourself and StructureCraft, where should they go?
Yeah, head to our website on StructureCraft.com, but also follow us on social media. We just recently launched this really cool new building we got to design with Bjarke Ingels, which, as you mentioned earlier, has got this awesome kind of traditional and yet modern approach to creating all wood joinery. So posing the question, could we take all the steel plates and screws out of our joints, which has been a really fun design process. So definitely be sure to check that out. And yeah, just email me if you're interested to talk more, and would look forward to hearing from you. And thank you, Adam, for having me on the podcast.